Good afternoon, my friends. I hope you're having a great Tuesday. I'm forgetting which day of the week it is. I'm on holiday this week, so yeah, for once I can actually forget about which day of the week it is for a change, which is kind of nice, you know. Hope you're having a great start to your week. Today, bonus stream, we are playing a little bit more Human Resource Machine. We played this on Sunday morning. It's kind of a puzzle game. Is it a puzzle game? It's a game that you can brute force a solution to if you have the patience to do so, but it's not a puzzle game in the sense that you're trying to get into puzzle logic mode. It's a puzzle game in the sense that you are really trying to solve like actual problems. We're going to warm up on duplicate removal. We spent a long time on Alphabetizer last time. We're going to warm up on duplicate removal, then maybe do Digit Explorer. This should be a slightly easier puzzle. You're fired. Ha, just kidding. But I do have a note here from your other supervisor. She's out sick today, but she says it's time to eliminate inefficiencies. And that's it. So send everything from the inbox to the outbox unless you've seen the same value before. Discard any duplicates. Right. That. Okay, we have a think about that. So, the first item cannot be a duplicate, right? So let's just start from obvious stuff, yeah? We're going to copy that to position 0. But before we do that, we're going to need to keep a counter as to where these things should be put. Yeah? So before we grab anything, let's copy from 14 and copy it to 13, right? So we've got 2 zeros that we can use. And the first thing we're going to do is grab something from the inbox and copy it to 13. And 13 is going to be called final position. Okay, 13 is going to be what counts up. Yeah, and it's going to tell us the final position of items that are unique so far. Okay, so we're going to copy that to final position. Now for the first one, we know it cannot be a duplicate. Yeah, so let's just go to the outbox. Then we're going to need to grab something from the inbox, and we're going to need to check it. We're going to need to check it from 0 all the way through. So we're going to make 12. We're going to make that I, yeah? And right at the start, we're also going to copy to I. I is going to be our stepper, and I is going to reset to 0 every time. And is going to go from 0 to final position and do the check before going to the outbox. Yeah? So, we're going to grab the second guy. We're going to grab him from the inbox. We need to okay, the first thing we need to do is we need to work out whether it's unique or not. And if it is unique, then we copy it to a position on the floor. So 10, we're going to call test. Yeah? So the first thing we're going to do is we grab it and we're going to copy it to the test location. Then we're going to be already holding test. It makes sense for us to grab things and then minus test from the thing, right? Or does it make sense to grab test and minus each number from it? And it might depend on when we want to bump up I. So let's just make a decision initially. We're going to copy to test. Well, we're going to now have that in our hand. So let's copy from I. We're going to subtract test. And if 0, then it's going to be not unique. Fine. Okay. Right, from 14, copy to the final position, copy to I. So these are all going to be zeros. The first thing, we're going to grab the first item, copy it to 0. We're going to... The first thing I think we want to do is... Oh, this is a really tricky one. Right. There's several things we want to do. And the order in which we do them is kind of important, right? We need to take something off the conveyor belt and we're going to put it in the test location. We're then going to test it against everything that's currently on the floor. And if none of those ever equal 0, then test is going to get put into whatever the next position on the floor is and get deposited in the outbox. Right? So, okay. So the first thing is I think we need to do the test to see if we've reached the end of the track first, right? I think we need the test to see. Let's get rid of all of that. Right. So we're going to 0 this up. Are we at end? Right? We are going to take what's in I, subtract what's in final position, and if 0, so if I has made it all the way up to the final position, we are going to copy from test, we are going to bump up final position, copy from test, copy it to final position, the next location, and then outbox it, right? And if not 0, just jump down to here. So, okay, if we're not at the end, so before we do this, then we need to actually get the data into test, right? So the first thing we're going to put the inbox into the testing position. So we inbox it, and we're going to copy to the test location. Yeah. This jump we can actually get rid of that jump, and then we'll just put the next test in here, and that will save us a step, but it will make our code harder to read. Now, we won't worry about looping through and making the test just yet, right? Because after we move the thing to outbox, well, let's see how this goes so far, just for the first one. Yeah, it's going to be much easier to debug it. Okay, so first of all, we're going to have 0. And that's going to bump final position up. So we're going to... Yeah, it means we're going to be a 1 array indexing rather than 0 array indexing. So... yeah, that's not ideal. That's not ideal. So maybe... it's probably not a problem. It's probably not a problem. It's probably just like not the most efficient way of doing it. But okay. It's going to pop the data then into the final position and then outbox. Final position needs to stay where it is. We then need to copy from 0. Yeah, and put that and reset I, effectively. And actually... no, do you know what? We're going to bump up final position afterwards. Yeah, because then that will put it into the 0 spot. We'll do it after outboxing the number, right? We increment final position. Yeah, okay. That's better. That will start us in the 0 spot. So we grab D, and that's going to go to 0 and get back to the outbox, and then final position goes here, right? And so that we can... it's actually recording final position as well. Strictly. Okay. So that's going to get us our first digit down. That's going to get us our first digit down. We then, if that's not 0, we need to test the next number. So if we're not at the end, what you have to do is you need to take what's in test and subtract it. So copy from test, subtract what's in position I, yeah, because this is a test to say are we end. We are at end. Okay? Everything in this loop is before you reach the end of the floor. So the first thing we're going to do, we're going to copy from test. We're going to subtract what's in position I. If that is 0, it is not unique. If it is not 0, we need to bump up I and jump to here. Yeah. And actually, in the very first time, we might be able to save one line of code here, but let's concentrate on getting it working first. Okay. Because if it's not 0, we're going to bump up I and then jump, and then we're going to subtract this final position plus 1, and then if that's 0, then we know that we've got a unique number. If it's 0, we know it's not unique. And if it's not unique, we actually need to disregard it, and we grab the next number from the inbox. So we don't even need that. Okay. So let's see how this goes on. I think we need to reset some numbers to 0 at some point. No, actually, we've already got that in there. Okay, let's give it a go. Let's see if that works. No. Not sufficient. Right, okay, where did we go wrong then? Okay, we grabbed the inbox, we copied it to test. We're going to see if we're at the end. And we are. So we're going to copy test, we're going to copy that to final position. There we go, and then we are going to bump up final position and reset the counter. Oh. Right, yeah, okay, we now need to jump. Right. Oh, so actually that's the one that gives us the inbox. Oh, yeah, okay, cool. Right, so I think we're okay now then. Let's see if that now works. Okay, it's recognised A. Very good, very good. Recognised D as being unique. This is going very well. I think we might just about have it. Oh no, really? It fails on other possible inputs. I will give you some inputs that cause your solution to fail. Fine. What inputs are going to cause my solution to fail then? So B, E, fine. C. Okay, so far so good. Should recognise D as being unique and goes down here. Okay, what went wrong there? Why did it reckon A was unique? So it picked up A, put A in test. I hasn't been reset to 0. Yeah, okay. Why isn't I getting reset to 0? Jump if 0. Right, Right, okay. Jump if 0. We need to copy from 0, actually. Yeah, okay. So this jump if 0 doesn't want to jump to there. It wants to jump to there. And that should now do it. We didn't reset I on one of the branches. So that's okay. Let's see if that looks a little better. So far, so good. Hey, very nice, very nice. Okay, how do we get 17? 17 or fewer commands. I'm not sure how we... Oh, JR plays games in the chat. Hello, sir. How are you? Good to see you. Have some hype emotes. 20 trimming 3 commands would be a bit tricky in that one, but you know, a win is a win, right? A win is a win. So that was duplicate removal, which theoretically was our warm-up level. So now we're going to go to digit exploder. Probably save a couple of lines by reusing the reset to 0 part. Ah, see, this is what happens when an actual programmer comes into the chat. No, I've never been more than an amateur programmer. Our users have been rating some of our hardware products with 1 star, with user reviews citing draws too much power and overheats. Numbers are too complicated for test subjects. Occasionally removes alarming volumes of skin from human users. So management has come up with a solution to make the numbers smaller and easier to understand. Grab each number from the inbox and send its digits to the outbox. For example, 123 becomes 123. Interesting. Okay, we're going to make some assumptions here. We're going to assume that all of these numbers are going to be less than 1,000. Right, we only have to do hundreds, tens and units. So what is the best way to do that using only addition and subtraction? You need to take the number, subtract 100 from it continually until you end up with a negative number. Then you need to add 100 back to it, and that gives you and the number of times you did that is the number in your hundreds unit column. And the remainder will be your tens and your units, and then you do the same thing for your tens and your units. And then we'll drop the whole thing in the outbox. Interesting. Okay, so we'll call this H count. We'll call that T count. And we'll call that U count. And we are going to start by zeroing everything out. So then what we want to do is we will take sub, then we need to copy it to the floor and bump, because bumping up the count puts the count into your hand. So you have to store that number in memory somewhere. Okay? So we take a number from the inbox. We can sub it first. We can subtract first. So we're going to subtract H count. If it's negative, we're going to have to go and do something. We'll need to re-add. If it's negative, we'll need to re-add h count. This, I don't think we're going to get anywhere near ideal numbers of things here, because the best thing I can think of is to effectively write the same code 3 times for the different columns. And there's probably going to end up being a way that you can make the code 1/3 of the size that I'm about to write it. But we will see how that goes. Yeah. Oh, do you know what, actually? Yeah, you probably can. You probably could take a block as being the column value of the memory that you want to look at, and after you've done the hundreds, you could increment the column index and then run the same code again, but now it looks in the tens column rather than the hundreds column. Possibly that might be a way to make the code like a lot smaller. I don't think I'm going to write it that way, because that's going to be harder to get working, I think. Read is probably unnecessary. Sorry, that says re-add. Re-add. We want to re-add the h count there. You might be right. I'll think about that. Hang on. So, we take a number out of the inbox. We're going to subtract. Oh, well, we're subtracting h count. That's the wrong one anyway, right? We're not subtracting h count. We're subtracting 100. Okay. We're subtracting 100 from it. If that's negative, we need to... Okay, if it's not negative, we are going to bump up h count and basically do the same thing again. Subtracting 0 is not going to do a lot. That's true. That's one of the fundamental rules of mathematics, in fact. Take a copy of the test number with every loop so that you have the number that you're looking at. We could do that, but I reckon you don't need to before you do the first subtraction. We do need to store the intermediate number before we do the bump. That's a really good point, because bumping puts the bump into your hand. So we do need to do a copy to test. Okay, so we subtract 100. If that's not negative, we're going to copy that to test, bump up the h count, and jump back, subtract another 100. As soon as that goes negative, we're going to add 100, copy it to test, copy from h count, and outbox it. I guess copy from test and add 100 will do the same thing, except you could reuse copy from test later on when you finish the tens. Well, so my thinking is that by keeping test as... So I don't think we need to record the original number, because what test is going to end up with for this first number is it will end up just being 86. So then we can start working on the tens without having to get rid of the initial 500 again. That's sort of my thinking. Because, like, I don't think the original... I can stop backseat musing of that. No, I know. Like, I think this is basically pair programming, right? This is like... developers love doing pair programming. I get the impression. This game is very, very close to actually being work, though. Although not really being work for me, because I'm not actually a developer. But, you know, this is... I imagine this is very close to what writing code is like. That's not true. That's a joke. Okay. Right. So we're going to outbox the first digit from H count. The next thing we're going to do then is we're basically going to take the same code, but we're going to take a copy of the same code, but basically do now the same thing for tens. And then once we've done the tens, we just outbox the tens and then the remaining number. So actually the copy from 0 and the copy to U count, not important actually. The U count we're not going to use, so we can save a command there later. We'll save a command there later. For now though, what we have in test is 86. So after we've outboxed the H count, okay, we're then going to copy from test. So now tens. Okay, we're going to copy from test, and we're basically going to take everything from here, and we need to kind of copy it. And I don't think there's an easy way, like you can copy the whole code. If you're into code reuse, we could copy 110 to the number testing against and reuse a bit of code where you compare against NTA rather than 100 and then 10. That is a good point. You could do that. You could do that. Because, yeah, rather than sub 10, you could sub a reference which could point to one or either of these two. I think. Yes. Okay. Let's write it out longhand, because that's kind of what I've got in my head currently. But what we need to do, copy from test is basically the equivalent of inbox here. So then we're going to sub 10, jump if negative, copy to test, bump plus T count, and then we need to jump back to here. No, yep, jump back to sub. And then after the jump if negative, we need to re-add a 10. Copy to test, we are still going to need copy from T count, whoops, copy from T count, outbox, and then what's left in test is just the units, so outbox and outbox. And then we need to reset the whole thing. So we'll copy to 0, copy those, and then grab the next item from the inbox. So jump all the way back to here, and we can get rid of U count, because that's not doing anything. And maybe that will work. So let's give it a go. Meanwhile... oh, no, that's no good. But let's have a look. Technically, you don't have to test against units, since whatever's left over after testing against 110s is by definition units. Yep, totally agree. Chuck the test number in the outbox at the end. Yes, absolutely. Reuse the register for H count and T count, so you can reuse the bit of code to output the 100s and the 10s. Right. Now, hang on a second. Where did this go wrong? Oh, did I bump the wrong thing? Right, we bumped H count. Okay. We need to grab... right. After bumping H count, we need a copy from... Yeah, okay, we'll just copy from test here. And we're going to need that again here. Right, let's try that then. Oh, no, you cannot copy from an empty value. So actually copy from needs to be after the bump inside the loop then, probably. Shouldn't matter down there. Oh man, okay, right, no. Something's going wrong. Something's going wrong. Wait, what are we doing wrong here? Okay. Zero seed that. Then. Sub 100. That is negative. So now we're going to add 100 back to it. Copy that to the test. Oh shoot, it's not going to accept 009 for 9. Yeah. Okay. Fine. So this is fine though because we have a jump if 0. So we just need a subroutine that says ignore 0. Ignore zeros. Right? So we'll grab the number. The first thing we do is sub 100. If that's negative, we're going to add 100, copy from hcount, jump if 0 to ignore zeros. And similarly, we're going to need one for the 10s as well. Yeah, but that's fine though, because 103, you are expecting the O. It's only leading zeros. Oh, right, okay, but 9 will have 2 sets of leading zeros, in fact, won't it? Oh, no! Oh, that's a nightmare. Okay, hang on. Right. So we're going to ignore 0. I can think of a bad way to do it. I can think of a bad way to solve it. What we need is we just need a bool which says whether we've hit our first digit yet or not. And we'll make the bool like 0 or not. So hit first digit. Like it's a pretty rough way of solving that. But what we'll do is we'll copy that to our bool. Okay, so this is hit first digit and it is 0. So So, if it's 0, for the hundreds we can just jump it if it's 0. For the 10s, we sub 10, copy to test, bump T count jump, add 10, copy to test, out. Okay, copy from T count. Jump if 0. If that's 0, we need to go go and copy from hit first digit, and if that's 0, jump to ignore 0. Right, otherwise we don't need to jump to it. Yeah, we'll just go here. Hit first digit. It's looking pretty horrendous now. After you've outboxed a value, we can just bump up hit first digit. Now, all we are doing right, so we need to jump up here and jump it into the 10s. Yeah. And if we jump in there, and if that's 0, right, then I'm just going to jump straight to the units. Man, that's pretty horrendous. Okay, let's try it out. $48. We've got. Hang on, is that working? 4. It might be working, it might be working. 7, 4. And then it's skipping, and then it's just putting 9 out. We did it! It's pretty ugly code. It's pretty ugly code. I don't think we're going to be anywhere near. No! No! Your solution works with those specific inputs, but it fails with other inputs. Why? Come on then, where does it fail here then? Okay, so it's not on the hit first digit. Hang on, wait. So skip back then, right the way back to when we pick the number up off the conveyor. Okay, so we're going to pick 502 off the conveyor. Right, it's because of the 0 in the middle. It's because of the 0 in the middle. So we're putting 402 down. We're going to count it up. Fine. 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 So now it's negative. So we've got a 5 on the conveyor. And we've hit the first digit. Right. We need to... There is no 0 to grab. So now 10s. So we've bumped up hit first digit. Now we're going to copy from test. Subtract 10. Well, now that's negative. So we're going to add 10 back to it. Copy that back to test. Copy from T count, which is 0. Fine. Jump if 0. Copy from hit first digit. Right, okay, we're missing a copy. Right, we then copy back from T count and then go to the outbox. Okay, this should now be working. Right. This should now be working because we put the bool into the output rather than the 0. So. Okay, how bad was it? How bad did it end up? 30 or fewer commands. I mean, you know, we only went over by a third. And we only nearly doubled the speed, so... Okay. Do we do prime factory? Do we do scavenger chain? Okay. Let's do prime factory. This is arguably going to be probably, because this is the optional one, this is the final optional one as well, so arguably this is going to be the most complicated puzzle in the game. Are you sure you're supposed to be here? This is a very difficult assignment. I have no idea how to do it either. For each thing in the inbox, send its prime factors to the outbox in order from smallest to largest. Prime factors. Okay, so a prime factor would be a number where when you subtract it iteratively you will eventually reach 0 at some point. Taking a number and factorising it into its primes is not terribly straightforward to do, except by doing it iteratively, because that's all cryptography and stuff as such. So I don't think there's a neat way of doing that, except to probably first lay out a whole bunch of primes on the floor. Like, work out a whole bunch of numbers that are primes. Emon Economist in the chat. Hi nerds, what's happening? We're playing a little bit of Human Resource Machine. It's a programming game by Tomorrow Corporation, and essentially it's a game that's so educational it's barely even really a game by this point. But the idea is that we have a problem and we're going to write some pseudocode to try and solve the problem. This is level 40 of 40. So it's the final optional level in the game, right? Arguably, probably the hardest one in the game. And we've just started this level, so we're discussing how best to tackle it. I'm thinking we go and lay out a bunch of prime numbers, and then we test the prime numbers. How many prime numbers are we going to need? I mean, how many prime numbers even are there between 0 and 100? Like, I have a feeling that rather than testing for numbers being prime, the first thing we do is we literally just lay out a bunch of prime numbers, because we know what the prime numbers are, because we are, you know, humans who have some experience with maths. We don't need to work out what the prime numbers are, because they can't vary depending on the inputs. So let's go for it. So 24 is not a prime number. That would factor out into 2, 3, and 8. No, sorry, well, 8's obviously not a prime number, so Yeah, it'd just be 2 and 3, because it's 2 times 2 times 2 times 3. So the answer that is expecting... Oh, there are 24-ish primes under 100. Yeah, okay. Yeah, I suppose probably about that. Maybe? Maybe slightly fewer, because I don't think it's like 1 in 4 numbers as a prime. But it's going to be something not terribly far off. Maybe that's like 15 prime numbers or something like that. But okay, well let's go with... This is going to be a really janky way of doing it, but first of all we're just going to lay primes. So, we're going to leave this as 0. We are going to copy that to 23, and we're going to bump and bump. Then we're going to copy to 22, bump it again. So that'll make 2, 3, then we need 5. So we'll bump that twice. Then 7's going to go there. Then the next one's going to be... so then the next one after 7 is 11. So we're gonna add 2 to that twice. So what we'll then do is we'll add 23 and add 23 and then copy that to position 19, so that'll get us 11. Add 23 and copy that to 18. So that's going to be 13, that's going to be 11, that's going to be 2, 3, 5, 7. Do you know what, rather than these bumps, could have actually just added 2 each time, couldn't we? Oh, can I make that 2 look less terrible? That'd be good. So copy to 2, bump, bump. Copy to 3, bump. Copy to 5. Rather than bump, bump, we're just going to... We're just going to add 2 and then copy that to 5. And then again we can add 2, copy that to 7. Okay, let's start seeing how that's going to work. Right, great. 13 and 15? Nah, that's all sorts of wrong already. Copy to them. Right, get rid of that. So yeah, we want to add 2 twice, and then we're going to add... Right. Is that going to be enough? Shall we try with that? There are 25, are there? That's weird. I wouldn't have... like, it's not really something I've ever thought about, but I wouldn't have thought, like, intuitively, that a quarter of numbers under 100 were prime numbers. It's like everything that's a factor of 2 is immediately out anyway. So you're basically saying that there's a 50% chance that any given odd number is a prime number, which is interesting. Now, this is actually a really good point, right? If they return, and they have as well, sneaky. If they give me prime numbers in the input, I have to recognise those as primes and just send them to the output. Let's assume that, say, the first 5, 6, 7 primes are going to be enough here. Ah, okay, the early primes pull up the average. That's fair enough. Okay, what we're then doing is we send its prime factors into the outbox in order from smallest to largest. In order from smallest to largest. So we're testing at the top and we're working our way down. And we also want to add a test to just make sure that the number definitely doesn't end up like at least larger than your current number. Okay. We're gonna have an incrementer here. So copy from 0 and then copy that to our incrementer. Grab a number from the inbox. We really want a number. What are these numbers? 17, 18, 19, 20, 21, 22, 23. We really need a positional number, actually, which we're going to lay. We're going to lay that at the beginning. So we've copied to 13. I'm going to quickly add 11 to that. Copy that to the position and bump it down. Right, so that gives me 23, which is the memory address of the first prime number we're going to start checking against. Okay. So then, we grab a number out of the inbox. We might as well put that number into our test position. And what we're going to do is we're going to substitute... Well, sorry, subtract pos. If negative, whatever. If 0, it's a prime factor. Right? If 0, it's a prime factor. At that point... Oh, wait, no. Because then you need to then divide the test number by its factor. Hang on. How do you divide something by 2 using only subtraction? You need to... You need to keep a count of how many times you've subtracted it before it gets to 0. You need to keep a count. Because you need to subtract 0, subtract 2, keep subtracting 2, and if it's negative, then that's fine, then 2 isn't a factor. Serious Kin, woohoo, streaming my work. How are you doing, Serious Kin? Good to see you in the chat, good to see you. Yeah. If you... So you need to keep subtracting 2. If you subtract 2, keep subtracting 2 and it becomes negative before it becomes 0, then 2 is not a factor. That's fine. You just go back to your original test number. If it does reach 0, then you know 2 is a factor. But then you need to know how many times you've subtracted 2. And you need to add half that number back. So you need to divide the count itself by 2. Wait, that doesn't make sense. So like 8, for example, you're going to subtract 2 4 times from it. Wait, no. Maybe I'm overthinking it, because the count is then how many you've got. Ah. Wait. Every time you subtract... Okay, let's think of a number like 10. You're going to subtract 2. You're going to end up the count being 5. Well, that is the number. That is the number that remains, isn't it? This game is making you code the math library of any language. That's really low level. It's very low. Yeah, I mean, this is an assembler style thing. The challenge is, for each thing in the inbox, send its prime factors to the outbox in order from smallest to largest. Now, I'm assuming that something like 8 is not expecting 2, 2, 2. I'm expecting that 8 is only expecting 2. That's the answer. But I don't know. That's an assumption. So, for example, 12, I'm expecting the answer to be 2, 3, not 2, 2, 3. Do you have any kind of expected input-output? So the inputs are over here on the left, so the first thing it's going to give me is a 2, which I need to correctly identify as literally being a prime number, which also doesn't have any other prime number as one of its factors, and then I just need to output the number 2. Similarly with the number 3. For 14, my expected output is going to be 2 and 7. But it's not guaranteed that... So I'm assuming that we're only going to get numbers where 13 is going to be like the highest factor to them. I'm also assuming that we're not going to get 0 as a potential input. First get the square root of the number. Very good, very good. No, but I think the count is correct, right? Because if you take 3, so let's think of a number like 12, right? It's going to, no, actually 12 is a really bad example. Let's think of a number like 3 times 5 is 15, right? So 15 is expected to be 3 and 5. So we're going to take 3 away. And how many times are we taking 3 away? Well, the count of the number of times we take 3 away is literally dividing it by 3, right? Because you take 3 away, and when it reaches 0, that's going to be your remainder. So let's not call this count, let's call it rem. Okay, right. We're back in the driving seat. So, we grab an item from the inbox, we're going to copy it to the test location. We're going to subtract what is in POS. Right? If you like this, you should try Exapunks anytime. So do you know what? We were actually discussing last night on the Monday stream what should be the next game that we play on Monday. If you've not seen my Taiji playthrough, you should definitely check that out. Because Taiji, it's almost certainly going to be my game of the year, for sure. Really, really great fun. So I think we finished the game in like 6 episodes or 7 episodes, and then we did all the late game content and the optional stuff. So the whole playthrough is like 13 episodes in the end. You'll watch it when you finish Taiji. Fair enough, fair enough. But yeah, give Taiji a go. Really good game. Really, really good game. And we were discussing what we're going to play next. So we're going to play The Looker on stream next, because that's kind of like a bit of a palate cleanser, a bit of a fun game. And we were discussing playing a Zachtronics game. Maybe not Exapunks, maybe the more recent one that he's done. I'm not sure. I've played a few games by Zachtronics. Opus Magnum was really great. Infinifactory, really liked that. I think it was called Infinifactory, or no, yeah. Sorry, I get it mixed up with Factorio. But yeah, Infinifactory, that's really cool. I like that game. But yeah, never played Exapunks. Haven't played his latest one. Their manuals can and should be printed. Yeah, that kind of makes it harder to stream, though, if you're working on literal paper manuals. A friend of mine bought me TIS 100, 10 years ago or something, and really struggled to get into that. Really struggled to get into that. Okay. So, we're going to copy the number to test. We're going to subtract position. If it is 0, sub pos. If negative, you need to basically just copy from. If negative, you're going to copy the number back from test. You're going to bump down pos. And you're going to loop round, because this number not a factor. If it is not 0 and it is not negative, you're going to subtract again, which means remainder goes up, and then you're going to subtract pos again. If where you get to, okay, if you get to something that's negative, then you need to reset, don't you? You need to copy from 0 and copy that to remainder. You need to bump down pos to move us down here. Resetting pos is going to be a pain. I probably should have counted these up, not counted them down. But okay. If you get 0, then that number's a factor and you can export it, right? Yes, you can. Yes. If it's negative, you know it's not a factor. So we take 0, we put that back to the remainder. We're going to bump up pos, no, bump down pos, and then put test back in our hand, and then start subtracting pos again. Right. If it is 0, then it is a factor. If it's 0, it is a factor. So what you need to do is you need to copy from pos. It needs to be this. Yeah, you need to copy from pos and outbox it. Any chance we can find the highest prime factor first? We could, actually. That might be easier. Might be easier. Don't know. Also, hi, I'm on Economist. Okay, you're going to copy it from pos, you're going to outbox it. You want ren to go to test. Yeah. You don't want to change pos, actually, because do you know what? It might actually be easier to output 2, 2, 3 for 12, right? Get it to test 2 again, and then keep looping round until 2 is not a factor anymore. So copy from pos, outbox it, take the remainder, put the remainder into test, and then we'll still have test in our hand, so start subbing pos. Now at some point some point it needs to realise that it has to stop, because I've written a whole bunch of you would have to divide it by 2. Again, yeah. But I think that might be a test that's necessary. Not sure. Now, at some point, your remainder is going to be 0, right? Because what you've done is you have a jump if 0, copy from pos, outbox it, and what you have left is 0. So copy from rem, and if that is 0, now do a reset. Serious kin. I'm going to return to code for money now. That's cool. Drop in the chat, Serious Kin. What are you coding in? I'm presuming it's not assembler, but if it is, mad props. That would be pretty crazy. I don't think I've ever actually met a real life assembler programmer. Okay, we have to reset. We haven't actually used I at all, have we? We didn't use I at all. We've just got a random index that does nothing. What was I even going to use I for? Web software, mainly use Ruby, with a bit of help of Java and Python for other modules that need way more optimizing. Fair play. I think what we want, right, we're going to copy out there. We can get rid of this I. We're not using this I for anything, right? But actually we're going to... I don't know. My variable naming is terrible, but start... Actually... Oh, no, do you know what? I'm literally just going to call this 18, 19, 20, 21, 22, 23. It's literally... It's 23, isn't it? That's just going to be the value of it. So, copy to 23, which is in memory address 0, so don't let that confuse anything. And then, we don't need to copy from 0. Don't worry about that. Right, copy to 23. What we do when we reset is we copy from 23 and we copy that to pos. And then I think we're ready to go and grab something from the inbox again. Alright, who's ready for the first go at this bit of code? Full stack dev here, JR, C# for most back-end stuff, although have also used Python for stuff, JavaScript for front-end, React, Angular, depending on how fancy you're feeling. Wow, full stack. Love it, love it, love it. What are you deploying? Where are you deploying? Are you deploying in your own infrastructure? Are you deploying in someone else's infrastructure? Or are you shipping on CD or on FTPs, shipping locally installed code? How code is run is genuinely a real topic of interest for me. I spend a lot of time thinking about how code is run and where it's run. Very interesting stuff. Okay, let's give it a go. So, we're going to stick our prime numbers out, and then... Okay, right, we've immediately gone wrong. So, copy that to the test. First thing we're going to do, currently working on internal applications. We do have a couple of client-facing applications, mostly hosted on our company's infrastructure. We do have a project to move it out to Azure. That's amazing. Right, so this is 0. So copy from pos and outbox it. Ah, we don't have anything in rem. We don't have anything in rem. Can we just seed rem with a 0 to start us off? We should be able to just seed. We should be able to just seed rem with a 0 right at the start. Ah, now it's not giving us 2 to start us off this time. It's giving us 14 to start us off. So here we go. 14 minus 2. Oh, now we're doing 1 minus 2. No, this has already gone wrong. This has already gone wrong. Stop. Oh. Didn't mean to say stop. Meant to go back. Okay. So 23. So 20 minus 2, that's 18. We are bumping rem, but we are not then taking a new copy of test. So, 18. It is not 0. It is not negative. That's some ugly prime initialization. What do you mean? This is brilliant prime initialization. You know, it's expandable. We've got so many more memory addresses that we can hold more prime numbers in. I'm not going to test whether a number is prime every time. Well, I mean, that's the whole point, isn't it? Like, yeah, sure, yeah. I don't know, yeah. This is going to be the faster way of running the code, for sure. Right, when we bump up rem, your lines of code thing is going to be interesting. Yeah, maybe. I've tried to keep it quick by adding 2 rather than doing bump, but we'll see. Right, so I've got 18 in my hand. I want to bump the count without, right, can I copy it to test? Can I copy it to test? Copy to rem, bump, pause, copy from test. I should be able to copy it to test. Because I don't think test needs to just be the... No, because you don't know whether it's going to be a factor yet. You don't know whether it's going to be a factor yet. Temp. Copy to temp. Right. And then copy from temp. And what you're going to need is you're going to need copy to temp, bump up rem, copy from temp. Alright, let's give it a go. Okay, now we're holding 7. Okay, this is working slightly better now. And now it's going to be negative. So you go, no, resetting that. So, take off 3. Counts 1. Take off 3 again. Yep, counts now 2. Take off 3 again. It's now 0, so we're going to put that in the outbox. No, this has all gone wrong. This is going wrong. Right. So, it's recognised that 3 factor, so that can go in there. Now it's going to try and copy from rem. But rem is not the correct number. So we've divided it twice. The test number is 9, so rem should come out as 3. Fine. So we take the 3, we output it. Before we copy from rem, we need to increment rem. So that's one thing we need to do. Because we don't have an increment after we hit 0. And then we're taking rem and copying that to test. So that's where we went wrong. Okay, fine. So before we copy from rem, we need to bump rem, but that puts it in our hands anyway, so we don't actually need that line. Okay. We are starting with 17. So that's going to run through and it should identify not a factor. Okay, so now we're looking at... Oh shoot, 17's a prime number, isn't it? So that's not going to work anyway, it's going to get all the way through. Fine. Well, we know that's not going to work, and we also know that that therefore means that after we've copied to 23, we now need to go and grab... so 17 is going to be 7 plus 5 plus 5. Copy from here. Add 5. Add 5. Copy it to here, and that's going to be called 17. You're absolutely right, JR. We are making an assumption that there is a maximum size of number that they're going to deliver here. But realistically, how big can they go? Who can say? Who can say? We'll go with 90. We haven't seen any numbers that have been bigger than 20 yet. We'll go with it. I have confidence. Like, surely, you know, when you're trying to work out if something's a prime number, usually, don't you just look in the book to see if it's a prime or not? Isn't that how computers calculate it? It's just a big old lookup table, isn't it? Okay. I do need to check what time my guest's coming today. Okay, now I've got a little bit of time. Is that number prime? Well, you'd have to look it up. You'd have to look it up in the book, JR. Right? There's a database, isn't there, of all the prime numbers that exist. and you just look it up. Okay, rem isn't resetting. I can tell that's going to be a problem. So rem started as 6, and then it went to test. Rem needs to reset to 0. Yeah. You bump rem. So when it's 0, you output it. Yeah, you're going to put rem in test, but now you need to... Yeah, you're going to put rem in test, but now you are going to need to copy from 0 and copy that to rem. And then copy from test. Okay. Idea, says JR. How about instead of subtracting down, you add up from each prime number until you reach the test number? Oh my god, that's actually a much better way of doing it, isn't it? I think you're right. Because then you just keep adding until you reach a number that's bigger than the number you're testing against. that's all gone wrong. I think you might be right, because actually you just keep adding numbers until you get to a number which, when you substitute your test number, is either 0 or bigger than the number you're testing it against. So you maybe is it simpler, or does it work out to being similar? You don't have to worry about dividing. You're adding rather than subtracting, so you're not looking at how many times you need to divide. You might be right, it might be easier to do it that way. Okay. So, no, skip back. Right, what was the number we took off? 5 is the number we're taking off. So, we drop 5 in test. There's 3. Rem 1. Now it's a 1. Rem 2. Now it's a negative number. So, if negative, grab 0, reset rem. Bump position, copy from test. Next, sub 3, rem 1. Hang on. Yep, that's fine. So temp is 2. Now we're going to sub again. It's negative. Reset. Now 5 goes to 5. That's 0. So now, copy the 5, go to the outbox, bump up the remainder. Hang on, wait, why are we bumping up remainder? Because if 0, we want to reset the whole thing. Why are we bumping up the remainder there? Oh, we only want to bump up the remainder. Okay, no, stop, right. This is where we went wrong here, right. We are going to copy from remainder, and if that's 0, it's fine, right? But if not 0, then bump up remainder. And copy that to test. Okay. Maybe this will now work, maybe not. This is the joys of debugging code. It's sort of broadly working. It's like maybe working pretty well, but we'll see. So now we've got 0. So we're going to pop a 2 out here. Now we're going to grab the remainder, and that's not 0. So we need to bump the remainder up. No, because the number we picked out was 4. Pretty sure the number we picked out was 4, actually. Wait, is that correct? Oh shoot, was the number 6 rather than 4? Oh, maybe I looked at it at the wrong point. Okay. So the first number went through okay this time. It's maybe getting there. Dropped 17. It dropped 17 correctly. It's going to test through all of the things to find 19 right at the end. But it should, if it worked for 17, there's no reason why it shouldn't work for 19. Oh my god, it actually works! 53 commands. Oh my, what? 333 steps! I smashed the speed challenge! That's presumably because I spent so many lines of code seeding the primes. So I never actually had to work out what the prime numbers were at all. We just go straight for reading the primes off a table. Oh, that's sick. Nice. Oh, that's amazing. I'm pleased with that one. Okay, that's brilliant. Well, that, my friends, is going to bring us to 3 o'clock in my local time, which means that's going to be all I've got time for today. Thanks for coming along to today's bonus stream. Really enjoyed it. This will be up week next Monday, I think, as episode 5 of Human Resource Machine. We've got 3 puzzles left, so maybe one more episode of this, and then we'll have this one complete. Maybe we will have a go at 7 billion humans, because that is kind of an interesting game. A little bit different from this one, but kind of the principle the same. Thanks very much for watching. I will see you guys real soon. Have a great day. Bye-bye. Okay, so that can be the YouTube outro, right? For those of you who are still with me on Twitch, let's go and see if anyone's actually online, and we'll go and try and give them a quick raid.